Hi everyone, I am Dino together with Joseph and Ryan. We are going to show and interpret our results from the time series dataset we will use. We chose South Korea as our country and our data is from ADB Statistics. So this is our Excel file. I already arranged it by the variables we will use to regress later. So for our review, what is a time series? Time series is a chronological order of observations over time. The variables we choose is GDP, unemployment rate, inflation rate, government expenditure, and gross capital formation. Let's open this data now. This is data, a general purpose statistical software used by many economists, sociologists, and other professionals. Under here, it is the section for importing and exporting data sets. Here is for managing your data and other things. Here is for the graphs. Here is for the models and other statistical tests. Let's go to data editor edit, paste, click variable names, and this is how it looks like. We see that it is year 2000 to year 2017. So we can now X or minimize this. First, set it to time series by typing tset and then click the year. Click enter. So we can see that it is now in time series. After this, transform the variables into logarithmic forms by commanding gen and then the variable selected. Remember that do not transform the variables that has rate since it is already in the rate of change. The dependent variable will be the GDP and the rest will be the explanatory variables. So now let's transform GDP into log. Gen and then click GDP. Type log equals log parenthesis this. So as we can see, the GDP is turned now into log in the variable section. So we are now already transformed these variables into log. And now let's regress these values. These variables. So click this, and click the unemployment rate and inflation rate. And now click enter. So this is our result. As we can see, the standard error of government expenditure and gross capital formation is at 1 and so on. It means that these two variables are volatile. It can take wide ranges of value and it is changing over time. Government expenditure is negative and statistically significant determinant of GDP in South Korea at 1% significance level. In other words, a 1% decrease in government expenditure leads to a negative 6.37 of GDP in South Korea in the years 2000 to 2017 ceteris paribus. Gross capital formation is positive and statistically significant determinant of GDP in South Korea at 1% significance level. In other words, a 1% increase in gross capital formation leads to a 5.94% of GDP in South Korea in the years 2000 to 2017 ceteris paribus. Unemployment rate is negative and not statistically significant determinant of GDP since the p-value is greatly more than 10% of the significance level. Inflation rate is negative and statistically significant determinant of GDP at 5% significance level. In other words, a 5% decrease in inflation rate leads to a negative 0.25% of GDP in South Korea in the years 2000 to 2017, ceteris paribus.
Hello everyone, so this time we will discuss adjusted R-square and its relevance. After that, we will test multicollinearity and interpret the result. So first, what is adjusted R-square? Adjusted R-square is a goodness of fit measure for the linear regression models. This tool indicates the percentage of the variance in the dependent variable that the explanatory variables explain collectively. So how do we interpret adjusted R-square? So as we can see here, our adjusted R-square is equal to 0.7714 or approximately 77%. So it simply means that the independent variables substantially explain 77% of the dependent variable. So let's try to interpret adjusted R-square using these variables. So in this case, our dependent variable is GDP and our independent variables are government expenditure, gross capital formation, unemployment, and inflation rate. So we can say that government expenditure, gross capital formation, unemployment rate, and inflation rate substantially explain 77% of the dependent variable or the GDP log from the years 2000 to 2017 ceteris paribus. So that's how we interpret the adjusted R-square. So now we will proceed to multicollinearity. We will check if multicollinearity is present. So the command to test multicollinearity is BIF. BIF. So how do we interpret this table? But before that, let's define what is multicollinearity. So multicollinearity means that the independent variables have a strong relationship with each other. So how do we interpret this, or how do we know if our independent variables have a strong relationship with each other? So if BIF is greater than 10, it means that there is a multicollinearity. So it is very important to test multicollinearity because to qualify as a final estimate, you have to make sure that your model is blue. So to address multicollinearity is to simply omit explanatory variables or independent variables. But to omit a certain variable, there is a big chance that your model has an omitted variable bias. But in this case, our VIF, the values of our VIF is less than 10. It means that our independent variables don't have a strong relationship with each other.
So, after transforming the variables into log, doing the regression, and test using VIF and TOL, we will now test the heteroscedasticity using White's test. So, in determining the White's test, you need to input first ESTAT space IM test, comma, White. Then enter. So now, as you can see here, the p-value is greater than 0.05 or 5%, which means that we will not reject the null hypothesis. It means that our OLS is homoscedastic. Homoscedastic means that the errors in our regression model have constant variance conditional on the explanatory variables. It means that we can analyze the standard error and can now proceed to the next step, which is the Durbin-Watson test.
Hello everyone. We are now going to test the serial correlation using the Durbin-Watson. Type E stat D Watson Click enter. As you can see, the Durbin-Watson D statistic is 1.99. Based on the table, the D upper is 2.060 and the D lower is 0.710. So this result is in the conclusive region. So we are not sure if it has serial correlation or not. So we are going to do another test. The price Weinstein. Put all these variables again. And this. Make sure no error. And click enter. So as you can see, the Durbin-Watson statistic transform is 1.92. And based on the lecture in this PDF, there is no serial correlation when the Durbin-Watson is at 2. So if you are going to round off this at a whole number, it will become 2. For the final estimates, let's put all these variables. So we are going to use the new West, the modern approach. Put all these variables again, make sure no error, put lag, and then click enter. So this is our final estimates. As we can see, government expenditure, gross capital formation, and inflation rate are statistic significant determinant of GDP in South Korea, while the unemployment rate is still not statistic significant determinant for GDP.
So now let's have a recap on what we did on theta. First is that since our data is a time series, we need to identify in this data that it is a time series. And after that, we transform the variables we input on the data editor from our dataset to logarithmic form. Except for those um, already have rate because we did not transform it because it will be redundant to transform it to log. Then second, we run the OLS. We regress our data. The purpose of this is to check for potential issues against the Gauss-Markov assumptions. Then we go to VIF and solve. This is to check the multicollinearity of the data. So if multicollinearity is present, it means that explanatory variables are perfectly correlated with each other. In our case, it has very low correlation, no multicollinearity because it is less than 10. This. Then we check the heteroscedasticity of the data. We test it by using White's test. So in our data, the p-value is 0.5304. It is greater than 5%, which means our data is homoscedastic. Next is that we test the autocorrelation or the serial correlation of the data using Durbin-Watson. So in our data, our Durbin-Watson is 1.99, this, which is in the conclusive area. It is in between the D lower and the D upper. So because we are unsure if there is a serial correlation, that's why we proceed to praise Winston. So the transformed result is 1.92 here. And lastly, in the final estimates, we use the Newey West. Comparing to our first regression and the final estimates, unemployment is still not statistically significant. Still the same. So that's it. Thank you for watching. I hope you learned something. God bless and stay safe, everyone.